So for today's topic video, we're going to be talking about the unit circle, how to derive it, and what some of the basic information about it is. I'm going to start with deriving the unit circle so that once it's here, I can refer to it for all the other information about it. So you may have seen the unit circle in your class before, and you may be going, okay, how am I going to remember this? Because it sort of seems like you've just got random values all the way around it, especially in radians, which is what I'm going to be focusing on here. In other words, where you've got the pi in there. But there is a nice nifty way to just create it every time. Maybe not memorize the whole thing visually, but to be able to recreate it. And so here's what I do. I do, of course, first draw a circle. Okay, now I'm going to go ahead and tick mark this. I'm going to leave off the centers or the very, very middle of each of these quarters here. So I'm going to have a tick mark here, 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 and here. And then we're also going to have these center ticks, so I'm going to make them slightly bigger. Okay, now I'm doing that because when we derive this, I'm going to be skipping over these for the first pass. So let's see what happens. This starts at 0. That's our starting point. And now this angle right here, if you just remember that this is pi over 6, what you can start doing is basically just counting. So this is pi over 6. I'm skipping over the big tick marks. This one's going to be 2 pi over 6. That's going to be 3 pi over 6. 4 pi over 6. 5 pi over 6, and so on. So everything is pi over 6, and I'm just counting. Oops, 9 pi over 6 would go here, and this would be 10 pi over 6. 11, nope, skip those, 11 pi over 6, and 12 pi over 6. Now you might be looking at that and going, okay, but that looks nothing like the unit circle that I've been told to memorize. Well, start reducing these fractions and watch what happens. 2 pi over 6, well, the 2 reduces with the 6, and that gives you pi over 3. 3 pi over 6, 3 reduces with 6, and you get pi over 2. 4 over 6 reduces to 2 over 3, so you get 2 pi over 3. 5 pi over 6 doesn't reduce, so I just leave it alone. 6 over 6 is 1, so this is just pi. 7 pi over 6 doesn't reduce. 8 pi over 6, that's the same thing as 4 pi over 3. 9 pi over 6 reduces to be 3 pi over 2. 5 pi over 3 right here. The 11 over 6 doesn't reduce. And 12 pi over 6, finally, that's 2 pi. So notice, it's easy to just start with pi over 6 and just start counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's hard to memorize all those as is, but that's okay because you can just count over and then reduce all your fractions. Now, we did skip the big tick marks here, so I'm just going to start here now. This is 0. This tick mark would be 1 pi over 4. So as long as I remember that this is 0, pi over 6, and pi over 4, and I remember this pattern, I'm going to be able to recreate the whole unit circle. Because now with the pi over 4, we're going to do something very similar. I'm going to just count. So I'm going to skip the little tick marks. So pi over 4, 2 pi over 4. Well, 2 over 4 is a half, so that becomes pi over 2. 3 pi over 4. That doesn't reduce, so I leave it. 4 pi over 4. The 4's cross out, and you just get pi. 5 pi over 4. Doesn't reduce. 6 pi over 4. Well, 6 over 4 also reduces to 3 over 2. 5, 6, 7 pi over 4. Finally, we get up here to 8 pi over 4. 8 over 4 is just 2, so we're down to 2 pi again. So if you remember that pattern, start with pi over 6, just count. Start with pi over 4, just count. You can recreate the whole unit circle. And so I don't actually have this visually memorized in my head, but I can always pull it up. And I can always sort of do this process mentally a little bit as well. So just circling the angles we actually care about here. Pi. I mean, we care about all of them, but for all the ones where I got these two angles here, we're using the reduced form for everything that we do. Okay, so there's the unit circle. Now here's some cool information about it. For the three trig functions, remember you've got sine, cosine, and tangent. There's also the other ones, but you don't have to do too much to remember those. Just remember that cosecant is 1 over sine, and secant is 1 over cosine, and cotangent is 1 over tangent. And so you can just do everything we're going to do with these three guys and then do 1 over to get any answer you need for those other trig functions. So what's cool for these is there's a neat little thing you can remember for each of these quadrants. First of all, remember it goes counterclockwise. So this would be quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Oops, I want to save that for something else. So quadrant 3 and quadrant 4. Now what's really cool as far as all the angles for sine, cosine, and tangent, in this quarter right here, the first quadrant, all of them are positive. Over here in the second quadrant, cosine and tangent are both going to be negative, but sine will be positive. So sine is positive over here. Down here, sine and cosine are both negative, but that makes tangent positive. So tangent is positive right there. And then finally over here in the fourth quadrant, sine and tangent are both negative, but cosine will be positive. And so the most common way I hear to remember this is all students take calculus. There's probably others, but that's very useful for finding the sine of your angles. So what's really cool as well is that if you can just memorize the angles for sine, cosine, and tangent in here, here, and here, so if you can just memorize what the values are for these functions, you can find the values anywhere else by doing reference angles. So, for example, sine of pi over 6 is 1/2. Positive. That's that angle right there, and I just memorized that. But now, say I want to find sine of 5 pi over 6, and I want to find sine of 7 pi over 6, and I want to find sine of 11 pi over 6. Well, what's really useful is that I can just look over here for the sine of sine, whether it's positive or negative, and I can get the values for each one of these. So how does that work? Well, if I look over here at 5 pi over 6, and I just connect this to the origin like that, that reference angle is the same as this reference angle over here. So that should be 1/2. And then I look at, okay, I'm in the second quadrant, sine is positive, so that would be 1/2. Now I look at 7 pi over 6. That also has a reference angle. This angle right in here would be pi over 6. And since sine, this is not in either the all are positive or the sine is positive area, I know sine's going to be negative down here. So that's negative 1/2. Likewise for 11 pi over 6. That's got a reference angle of pi over 6 right here. So that's also going to be negative 1/2. So really, as far as memorizing angles, you only need to do it for the first quadrant and then know how to read this unit circle. Remember that all are positive here, sine's positive here, tangent's positive here, and cosine is positive here. And then you can just look around, see what the reference angles are, and come up with your values. One thing to be careful of is all your reference angles should be drawn with you thinking about the x-axis. So all of these, you're looking at the angle between the x-axis and your line. It's wrong if you do something like this. If you look at this angle, that would not give you the correct angle. So that's a common mistake, is to look at the y-axis. Don't do that. Always drop it down to the x-axis right here. So that's the unit circle. That's the way I come up with it, is I just count my way around and then reduce all my fractions. And for these ones right here, I would just memorize what sine, cosine, and tangent are for these three angles, and then you can just manipulate your unit circle to get all the other angles. And there we go. All right, now that you have that information presented in this video, perhaps you want to see an actual example where we utilize this information. If so, click here.